Hey guys, today's a great day to continue to work with radicals, okay? Very similar to what we've done before with simplified radical form. We talked about making sure you know your perfect squares. You're using the perfect squares to help you simplify them. The only difference now with these problems, as you can see down below, these problems are going to include variables, okay? And how do we take the square root of a variable that's being raised to a power? So we're going to address that concern today. Just as a review, we're going to go through the perfect squares. We should know them. We should know how to generate them. As we go through, we can just make a nice list, and that is super helpful when we're trying to find them. Okay, instead of trying to think of them in our head, it's a nice visual just to have them up here, so that we can work through them, see them, and we don't miss any of them. Okay, but this is our perfect square list, obviously generated by multiplying a number by itself, and this is up through 15. You do have to also be able to identify ones that are greater. These are super helpful to know. Just up to 15 would really become in handy, okay? So we're trying to put these in what, again, the notes say simplest radical form. You're going to also hear of it next year in Geometry Honors as simplified radical form. Okay, and we're going to take a look at number one. The same idea. We're looking for the greatest perfect square that goes into 45, which is 9. So we're going to rewrite 45 as 9 times 5. And then we look at x to the 14th. And the general rule of thumb is if the exponent is even, it's a perfect square. And what we're going to do is just divide it by 2. So we're going to leave it as it is, okay? I like to go through and circle our perfect squares. Again, since 14 is even, it's a perfect square. 9's a perfect square. It's one of the numbers that's up here on our list. And we're going to take out the square roots of those circled terms. So the square root of 9 we know is 3. The square root of x to the 14th, again, we divide by 2. We get x to the 7th. And the only thing that's left in the house is the 5. So 3x to the 7th root 5 is our final answer. Okay, so let's keep going here. This presents a new situation. We're looking for the greatest perfect square that goes into 18, which is 9 again. But now we come across an exponent that is odd, x to the 5th. Okay, x to the 5th, that exponent there is odd. So we're going to break it down. Okay, so we're going to rewrite x to the 5th as x to the 4th times x to the 1st, because x to the 4th times x to the 1st is x to the 5th. We're always looking for one less than the odd exponent, which would be 4, and we can just rewrite that as the product of that and the variable itself. Y to the 8th, since 8 is even, is a perfect square. So now 9's a perfect square, x to the 4th is a perfect square, and y to the 8th is a perfect square. So I like to circle those as a visual. I'm going to take the square root of those and pull them out. So the square root of 9 is 3. The square root of x to the 4th is x squared. And the square root of y to the 8th is y to the 4th. And now we can clearly see everything that's being left in the house. Okay, so the same thing kind of continues down here for number 3. The only difference is we have a number outside the house, so we're going to keep that number out there. Looking for the greatest perfect square that's on our list, which is 49. 49 times 3 would give us 147. X to the 8th is a perfect square, so we'll leave it. Y to the 13th is not. So we'll break that down to y to the 12th times y, and z to the 20th is also a perfect square. All right, so I like to circle those to see those. So now I'm going to pull out the square root of 49, which is 7. 7 times negative 5 is negative 35. This would be x to the 4th because we divide by 2, y to the 6th because we divide by 2, z to the 10th And what's left inside are all the terms that are not circled. And number 4 is more of the same. I'm not going to do it here because that's one that I would probably have you guys do in class. Great topic just to get back into the swing of things. There are 2 weeks left, guys. Make sure we know the concepts. Make sure we're watching the videos, doing the homeworks the right way. If you have any questions, make sure you're joining us live. All right. Until next time, I'll see you guys.